So, holy free holies, there are so many types of problems I could throw in here that I could go for hours and hours, but none of us want that. So, let me just pick on a few popular types of problems you might see. We're going to solve some triangles, meaning it might ask you to solve for x, it might ask you to solve for a missing angle or a missing side, but we've got to notice when we have a shape whether it's congruent triangles versus similar triangles. And the same thing with shapes, congruent shapes versus similar shapes or figures. So let's start with the problem where we have been told, or we can just see that we have two congruent triangles. Now, how do I know they're congruent? Well, SSS. So you might be given a picture like this, and then maybe you've got some labels going on. Maybe down here there's like a 32. Maybe right here there's like a 40, and then we'll put an x degrees up here. Maybe over here you have like a 2y plus 7, 3r minus 10, and then we have like, I don't know, I'll call that an r plus 2. Wow, isn't this exciting, watching me make up a problem? Okay, we're going to do, let's not do, let's call that 11. Okay, great. So here we have these two pictures. The triangles are congruent. We have all this junk marked up. So you're going to do a big comparison is what's going to happen. You need to look for corresponding parts to match up. And the reason you do that is because how in the world are you going to solve y and r and x if you don't know what to set them equal to? So let me start with the first thing I see on the left, which is this. So I have to look at the picture and know what to do with 2y plus 7. And if you notice, it's on this side that has one mark. So if I compare it to the picture over here, well, the 11 also has just one mark. So I have my first equation. I can just set corresponding parts equal to each other, and then I can subtract, and then I know that y is 2. Okay, so now let's go after something else. Maybe let's go for the angle now. So I need to figure out where x is on this picture on the left. Well, x should be the top angle, right? And you're probably thinking, you know, nothing's there. How do I figure it out? Well, you have two other angles, kiddos. And how much does a triangle add up to? Well, I'm going to put the x here. The triangle adds up to 180. So basically, I'm just trying to figure out what this missing angle is. So I could either just do some mental math, or I can write an equation where I do x plus 32 plus 40 equals 180. And then I can solve it that way. And I believe when you do the math, let's see, that's going to be a 72, and then I take that away. I believe you're going to get 108 for x. And I'll put the little degrees by it. There we go. All right, and then the last one is just going to be this r thing. So r has two dashes here, so I compare it to the one that has two dashes over here. They are congruent, right? They are congruent corresponding parts, which means congruence, I can set them equal to each other. And whenever I do that, I'm just going to solve for r. So let me add 10 to both sides. R plus 12, and then let me subtract r to get them together. So 2r equals 12, so r equals 6, right? Okay, so r equals 6. So now I have my first congruent type picture set up. So what if you're talking similar figures instead? Okay, now similar figures are the ones that have matching angles. So just a brief side note. Similar, let's do similar triangles. Similar triangles are have the same angles, but they do not have the same sides. They have proportional sides, which means that one picture has been dilated, okay? And you could do this with more than just a triangle, but for the sake of this video, I'm going to do a triangle. So you can note it's noticeable that one triangle is bigger than the other, and so their sides aren't equal, they're proportional. And that just means you get to set up a proportion and solve them. So just make sure you're looking at what I called corresponding parts earlier. So I'm going to do this, and let me just label up whatever I can here for you guys. Let's call this a 50. Okay, and then I'm going to put, let's put a y degrees up here. We're going to try to figure that out. And then maybe for my sides, maybe I have that this is I don't know. Let's do a 2 here and a 3 here. And then over here, let's do like a 9 and then like a 3x minus 1 over there. Okay, so I'm going to solve for x and I'm going to solve for y. So let me start with the angles first because I think that's a little bit easier. If they have the same angles or congruent angles, I can figure this out the same way I did the last problem, okay? Y is in the top of this picture and that's going to correspond to the top angle of this picture. So if you want, you can just put a y. I destroyed my picture. You can also recopy a y into this tiny one right here. And that's important also to help us get an angle. Now we also know that a triangle adds up to 180, but you feel like you're missing this angle here and you're like, oh no, I can't do it, I'm missing an angle. But you can do it because this is an isosceles triangle. See, if these two are marked, what's the rule? Two sides are marked congruent, then their angles opposite are also congruent. So I can stick my own 50 down here. And now I know that this triangle is 50 plus y is equal to 180. So what's y going to be? Well, it's going to be 80 degrees. So not too bad to solve that one out. It's just 100 plus y is 180. You could probably do that one in your head. So the angle part you just said equal like the last one. Not too terrible. Now what about this side length? Okay. So proportional sides means exactly that. What I like to do is start on the small figure. I call them like S and B, like small and big. And I sometimes go from small to big, or sometimes I go small, small, big, big, but you just have to be consistent. So I think what I'm going to choose to do is I think I'm going to do the small left side over the small bottom side. And then that has to correspond to the big left side of the picture over the big bottom. I'm immature. Okay, so you could do, we're going to set this ratio up. So if I look at my picture, what's on the small left? Well, the number 2 is on the small left. What's on the small bottom? The number 3. Now I look at my big triangle. What's the left side of the big triangle? It's 3x minus 1. And then what's the bottom side of the big triangle? It's a 9. And once you've made it this far, some of you guys have been doing great setting this up and then you get stuck. This is where you get to do the cross multiplying stuff, right? So I'll do it in different colors even to help you out. So we'll do this. Okay, so the first thing I'm going to do is this diagonal. So 2 times 9 is 18. And then I'll do the green, 3 times 3x minus 1. Now, I didn't do that in my head, guys, because I want to make sure that you see that this 3 has to be multiplied to everything at the top over here. Everything. It's going to get distributed. So 3 times 3x is 9x. 3 times a minus 1 is negative 3. And now we solve. Let me add that over. Okay, now 21, we have to get the 9 off the x, so I'm going to divide. Now, I don't know what 21 over 9 is in my head necessarily as a decimal or anything, and you don't have to either. You could just leave it as 21 over 9. You could turn it into a decimal. It's going to be like, what's that going to be? Like 2.3333. Whatever, or you could just leave it alone. Okay, so that's just a couple of examples of when it's similar, how to set it up, and then when it's congruent, how to set it up, and the different ways to solve. So hopefully that helps you guys out when you see a funky problem. I feel like I want to do one more that I kept seeing a lot of and everybody kept messing them up. Oh, I know what it was. It was this kind with parallel lines. These are fun, actually. I think of these as like ladder problems, ladder proportion problems. If you see that things are parallel and you see some transversals, what makes it really cool is that a lot of junk ends up being proportional. So it's like, I don't know, I'm just making stuff up right now. How about 3x plus 1 and then like 12. I don't know. Okay, so if you see a rando picture like this, what's cool about these is that you can just do little piece over little piece, and you can almost connect it any way you want, except don't do like diagonals. Like don't go 2x over 12. Like that would be a bad proportion. But you could do like this top over this bottom. equals this top over this bottom. That's what some people do, where they'd be like 2x over 5 equals 3x plus 1 over 12. Or, keeping with the pink and green theme, if you want, you can do left pink over right pink equal to left green over right green. And so see, here I went top to bottom, but then on this side I went left to right. So this is top over bottom, and here I was doing left over right. It doesn't matter. It'll work either way, and I'm not even going to solve it out. I just wanted to help you with the initial setup. But from here, of course, you would do the same thing we did a second ago. Cross multiply these, and solve. And then if you do it this way, guess what's going to happen? You're going to get the same thing. It's amazing. So anyways, so there's that last example. But good luck, guys. Let me know if there's other examples you find that are tricky that you want to see me do.